Hello everyone. Hope you are all well. And so come on, let's begin. So yesterday was 6th April and today is 7th. You know, sorry, I just did a mistake. The mistake is that today is 6th April Monday and yesterday was 5th April Sunday. So I'm recording my Sunday's video today. And because yesterday I was bit in studying and I was busy. Work came, so I couldn't record the video. I'm starting today, so let's start. Sorry for the late. So, as you know, we are going through the April reset. So this is my third video, and hope you are all well. So thank you for listening, and let's start. So today, first let's go uh, with the studies. Okay. So in the studies, I had the courses. Okay, so for the first course or the first thing in the studies that I did uh, from when did we last recorded was I think Thursday. Yes. So from Thursday to Sunday, what things I did are these. Okay. So first it was the first I did was this C++ course. Yes, this C++ course. In this, I did these things. I implemented this Monte Carlo simulation using Dijkstra's algorithm. So actually, it's a code written in the VS. It's a code where you have to find the shortest path in a graph. So first, let me explain you what I'm talking about using representation. So wait, let me go through the concepts. Yes. So here, let's see what I'm talking about. See, let's imagine there is a graph, okay, like this. Okay, let's change the color. So let's imagine this is A, okay. See, I'm using my laptop and my fingers to draw. So I'm sorry for the bad drawing and all, you know. Okay, so let's see. This is city. Okay, let's imagine this is a city. A is a city. Okay, this B is a city. C is a city. And D is a city. And E is a city. Okay, so let's draw a path. This color. Well, yes. C. This graph is a unidirection. So like, and as we can go from here, so we can come back here also. Okay, it is not a directed graph, means only in one direction, but it's a unidirected. That means we can go from here to here and there back also. Okay, so from A to B, let's make a road, and from B to D, let's make a road, and from D to E, let's make a road, and let's connect this here, this here. Okay, so imagine that this is a graph. Okay, first let's imagine only that this is a graph. Then we will add the points like C from A to B means from A to B. When we go from A to B, the distance is approximately, let's say, 2. So you can say this as a No, distance or oh wait. Okay, I'm sorry for the writing. Distance or wait, you can see this. Okay, so from A to B, the distance is 2. From A to C, let's say the distance is 3. And from B to C or C to B, the distance is approximately 4. From B to D, it is 5. And from D to E, it is 6. Okay, so what this graph does, sorry, what this algorithm does, Dijkstra algorithm, it just finds the shortest path, like which is the shortest path from A to D. Like if you want to go, let's say we have the starting city, okay, A. It's imagine this is the, let's say this is the start node. And let's say this is the, say this is the end node. Okay, so what this algorithm, first in this algorithm, first we make a, like three, you can say three lists. Okay, so first we make a three lists, like a notebook. You can say a notebook. I'm writing short because it's taking a lot of time. I'm just writing in short, because I'm writing with hand. Notebook. Okay, then another, it needs a, another list in which we store the bool value of a visited notebook. If visited, we write it true. If not, it's like false. Okay, so visited one, and the third is priority queue. Yes, and the third list is priority queue. Priority. Oh my God, how stay priority queue. Okay, so we take three lists, in which what we do is that we first mark the starting city A as 0, because see, this this means, let's say this is A, this is B, this is C, this is D. How much this is E. Okay, so for A, we are starting from here only, so we mark A as 0, because see, from A to A the distance is 0. From A to A the distance is 0, so we mark this as 0 in the notebook. This is for distance, like from A, from means the A, from starting node to A, how much distance it is, from starting to B, how much distance it is, and from here we are taking the start as A. So from A to B, what is the distance? From A to C, what is the distance? From A to D, what is the distance? So this we mark, this we write in this notebook. Okay, and in this notebook, visit. Okay, it's visited only, but I'm writing short. So in this notebook, we write true or false, as if we visited, we mark it true, as not, if not, then it is false. So as we are in A, so the distance is 0 and we are marking it as true. Okay, then true, let's write only T. Okay, it will be easy, it's true. And in the priority queue, we see all the neighbors, like from A to C, what is the value? A to B, what is the value? And Okay, A has two neighbors only, B and C. So we write, and this priority queue in the code we make it as a minimum, means it the priority queue bubbles up the minimum value. So in the priority queue we have two, you can say, a pair of value we store. Like first we store the, let, let me give it a green color. First we here we store the distance, okay, the distance or the weight, you can say. And here we store the node ID. Okay. So in this, what we do is like see 0, true. Then in the distance, we in this priority queue, we take the neighbors. So from A to B, the distance is 2 and node ID is B. And from A to C, then distance is 3 and the node ID is C. So as we know, it is a minimum one. So it will write here for the dist, and the minimum will bubble up. So here the minimum is 2. So the distance is 2. 2 node to the neighbor node ID is B. Okay, like this. And the third is 3 and the node ID is C. Okay, we have found all the neighbors. And now let's go. Now let's, what it does next is it cuts. Okay, then it picks the smallest from, it picks the smallest thing in the priority queue, and it comes here, okay, and marks it as visited, and then runs through this, like see what I'm showing you. Okay, so it will go to node ID B with distance 2. So here it goes from node ID 2, okay, goes here, then same, it will mark B as C. What is the distance? 0 plus 2. Okay, it was here, it was 0, and here it becomes 2. So it will mark it as 2. Okay, then so from A to B, the distance is 2. Okay, and it marks it as true. Then from B, it searches its neighbors, it finds its neighbor. So how it will do? So from B, there's only one neighbor, okay, to D. So what it here it does is distance is 5 and the node ID is D. Node ID is D. So it what I told, that it picks the thing that is top in the priority queue. So here the top is the minimum. So what it does, it again travels from here A to C. So C node distance of 3 and C. So it here comes here. So from A to C the distance is 3, marks it as true. Okay. Now what it does, now it finds the prey, now find all the neighbor of the C. So C has neighbor B. Okay, but before it sees its neighbor, it then what the condition check is that it shouldn't be in the, like in this notebook. If it is, the B value is there, like see here is the B value. You can see here this is the B value 2. So what it does, it doesn't writes this as, it doesn't write this as node ID B and 4, distance is 4 from C. Why? Because actually we have the means the shortest distance to B, and the value is 2. So why we will take the 4 distance of the node ID B? Because its aim is to find the shortest distance, but here the main aim is only like uh, breaking. So what it does, it doesn't takes the B value and it just skips it. So here, and the C doesn't goes to B, but instead the top priority queue is selected, like here, D5. Okay, so this one is gone. This is not selected. Okay, This is not written also, sorry, not select. This is not written only in this. So node ID D and the distance is 5 is again uh, gone in this priority queue, and in the notebook distance to distance D. See here from B to D. This is selected. Okay, from there it goes to here. So D. Now D value becomes 0 plus 2 plus 5, 5, 6, 7. So here the value becomes, see, 3, 4, 5, 6, 7. D becomes 7. Okay, so you are means noting this that in this notebook we are calculating the distance from the starting node to A, starting node to B, starting node to C, starting city to D, starting city to E. Okay, so D is 7. So we went to D. Now we find the neighbors. Okay, so this is not, not included. So we'll find the neighbor using this. Yes. So how we'll find, now D will see, D has only one neighbor, that is E. So here we'll just write D. Sorry, it is not D. From D we are going to E. So its neighbor is E, or E. The value is 6. So no other thing is here. So we'll just, and this will go into this, and E will become, see, this was this, this was this was this. Sorry, D was also true. D became true in the last time, and E will also become true, and E will be how much? 6, 7, 7, 8, 9, 10, 11, 12, 13. E will become 13. Okay, so we have now gone to E. So this is actually the algorithm of going from the start node to the end node. So this was the Dijkstra algorithm, and let's go to the code. Okay. Mhm. Yeah, so here is the code. So here this is the explanation I wrote for the code. Actually, my idea was this, but the AI has done the comment is done by the, means I wrote the comment, the idea was mine, but AI enhanced it. It uh, what I yeah, it decorated it. Okay, it upgraded it. Sorry, yes. So here we have the, see, we are including IO stream for IO and the queue for the priority queue I told, and the vector, vector is the list in C++, and the utility for pair, and the functional for greater, and the random for generating random graphs, because you will see in the coming. See for here, as I discussed that we made the graph, made the graph. Okay, so we are just making the graph, but here the graph is like in zeros and one. Okay, like a row, then each first we are making an array, and then each array is having and another array connected to it. We don't have time, so I would have been showing you this in the concepts, okay, in the drawing only, but we are going, it's very a long video will be recorded then, so I'm just summarizing it. So here we are making the private members, okay, that shouldn't be changed, and here we are constructing the graph. This is the this is the constructor of the graph, and here we are initializing 0, because see, from A to A it is 0, from B to B it is 0, from C to C it is 0. We are just making it 0. Here is the prop function that is responsible, a helper function that is responsible to generate a random number. This engine, this engine gets the gets the gives the random number. Okay, and you can see here double dist, and this dist makes it in between 0 to 1, 0.0 to 1.0. Here the engine is passed in this dist, and the engine is actually, you can see here. Okay, wait, you see this line. is what makes the engine. It is like making the engine generates random number, and the random number accessible to all, like every graph having a dice in a pocket. Okay, so it actually the main thing is that it generates a huge random number, and the dist makes it, and the dist this makes it this dist makes it in between 0.0 to 1.04 probability. And here we made a function of add edge that inserts an edge. We give a a u city to the final city, the city we want to go, and the weight, and just it adds a row. So actually, in these all, like see here, generate random edges. It generate edges according to the probability and density. Like if we go if we give 0.2, then it generates 20% of the roads, and 0.4 it generates 40%. So actually, wait, before the gets wait. This actually, yes, from here to all this here, we are actually making a random graph that is set with random edges, okay? So that we can calculate the Monte Carlo simulation, which I will be explaining that also in the end. So here the double gate weight, we are just having a method for the extra algorithm to get the weight, because see, actually we have put the vertices, here in the private, so the function cannot get it. The outer function, like here we have discussed this function cannot get that value because it is in the private section. So we are making a helper function that will help it to get the value. And here this is the int v that returns the number of vertices, the cities, and here it returns the weight. Okay, like the weight means what, the path, the distance from one node to another node. So this is the extra algorithm that is written in the code. It's from the start node, then this from zero. This is the priority queue. This is the visited what list, and this is the list. The notebook that we were talking about this year. This is the notebook that we are talking about, and this is the visited one, and this is the priority queue. Yes. See this line. This line, the greater, and this line makes the priority queue bubble the minimum value, minimum distance to upper to up. Okay. Yes. So we then push the value in the priority queue, and then we'll run a loop while the PQ is not empty. Actually, as we saw that at last the PQ was empty, the priority queue was empty. So while it is not empty, the loop runs and runs and runs and finds its neighbors, calculates the distance and all, and just this. And this is the law that we calculate the Monte Carlo simulation. Here, we just like run the loop 1,000 times. We then get the distance from the starting node to the end node of all the cities, and then we just divide it by the total number of count, means the total number of roads that we had and then their value. So we get the average. Okay. So here the average, we get the shortest path. And so this is the Monte Carlo simulation using the extra algorithm. So let's run the code first. So here we just write GCC plus G plus plus, sorry, the G plus plus extra dot cpp. This is the code's name into a file a.exe. Here it will compile. Come on. Yes, it compile. So we'll run dot slash a and c. You can see here. Yes, so see, for density 0.2, that is 20%, the average shortest path is 5.78. Means when the density is 0.2, means when the density is less, density is 20%, means the road are not so much connected to each other. And then the road is not dense. And the average shortest path is coming long because the roads aren't connected. And when the density is 40%, okay, means the road is likely more connected and more dense, then the average shortest path comes shorter. That is, we get the short roads, more short roads. Okay. So yeah, this was all for our C++ course. And now let's go to the next one. So yeah, next one was negotiation course, and for that I'm just wait. Let me get all the points. Oh, sorry, I paused the video because I actually went to get the notes where I had written, the course. So I just I can say did I did the course. I learned things like the BATNA best alternative to negotiated agreements. The BATNA, you must have like a plan B. You must have a solid plan B, best alternative. If you don't know your plan B, don't never go into a room for negotiation. Okay, and the reservation price, the red line. Like if the price goes $1 or so below the red line, then you just move out from the room. No emotions, nothing. Because the deal is of like worst value, no value, and the ZOPA, the sweet spot between your minimum and the forward person's maximum. So, on the three things you can say, the 3 points I learned in 3 points I learned three main points I learned is like one is preparation. Okay, at least prepare something before you go to the negotiation. Like preparation is 90% win. Because if you know the BATNA price, and if you know if you research before going into a negotiation, it will help you a lot. It will let you know the value of the product and all. Okay, so preparation is 90% win. The second is that shut up. Okay, shut up and listen. You often think the one who's talking more is dominant, is winning the negotiation, but actually, when we shut up and listen, the person who is saying is actually like throwing information, is actually letting information go, and the one listening is gathering and leveraging the information. So actually, shut up and listen. Ask how and what. Okay. Number third, the one telling is that expand the pie. Actually, I also have a little confusion in this, but the thing that is that uh, you should like the thing I want to tell you is that expand the pie is that stop fighting over the size of a slice. Okay, find the things that are low cost for you but are a high value for the forward of high value for the person next to you. There are things that you don't value that much, and the person next to you needs it very much urgent. So use that, expand the pie like a faster payment term or a testimonial. Okay, these are the things. And one thing, like one point I'm telling you is that just I learned is that the person who is most willing to leave the most willing to leave person is most willing to leave the negotiation or the leave the room almost always wins. Okay, if the means what I can't tell in Hindi, we say अगर सामने वाला आदमी. So it is like if the forward person gets the the sing, gets the sound, gets the hearing that he gets your intention that you are very much interested and you are willing to do this deal very much, then he will squeeze you out. Okay, so almost every time have the willing to leave the room, the person who is most willing to leave is always wins. Okay, so remember this line and say this is also a very much good thing. Let me mark it boldly. Yes. So for the Chinese, yes, for the Mandarin, I'm in the, I think, module module 3. Yeah, module 3 or 2, I think. The shopping. Oh, and here I learned is that, wait, let me first check it is module 2 or 3. So yeah, I actually saw it was module 4 of module 4. Okay, it was module 4. I like shopping. Okay, so actually this course is Chinese for beginners. So here I learned was this like what you what you like. Okay, let's say what you think of this. Yes, what you think of this. Okay, so this is said in Chinese is like uh, ni. Sorry, it's not ni. It's jug. I'm talking in respect of jug. Okay, so jug, mug. That's so it is said like jug zenmei yang. It's like jug zenmei yang. Okay, so what do you think of this? And if you like the jug, you say like if you like the jug, or if you don't, then we say like I don't like the jug. I don't like the jug, or I don't like this one. So we say this like wo wo不喜欢 like wo不喜欢. Who is not and she one is like I don't like. So she one is like okay. Who is not so 我不喜欢这个. So I don't like this one. 我不喜欢这个 okay. And if you like that one, see if I say I like this one. So for that we say 我喜欢 like 我喜欢. Oh, I have to pause because my mom is here. Okay, sorry, I will continue. Oh yeah, I'm sorry. I'm a little bit shy, so that's why my mom is here. My mom was here, so I had just paused. So yeah, we were in the. I like this one. So we say this like 我喜欢那个. Okay, so 喜欢 is like like. So 我 means I and na means this. Okay, na. I'm writing it here only. Na means this and sorry. Uh, Ja means that. This was it. And I also learned for the clothing, okay, that they taught in the course only for clothing also. So wait, let's. So for the clothing, like we say, what do you think of this? Like we say for clothing. Mm, I means I'm not. I can't fully understand, but what they are teaching, I'm just trying to say here, okay. So for the clothing, it is like Jia, the same Jia this. So Jia Qian Zhenmeiyang. It's same Jia Qian Zhenmeiyang. Now what do you think of this? And if like for the clothing, and if it is too large for you, then you say like Jia Qian Tai Ta Le. Okay, Jia Qian Tai Ta Le. So Tai Le is two. Like in Chinese, it is we say ni hao. So how is good? I think yes. Ni hao. How are you good? So how is good? So if we like tai hao le, so it will be great, too good. Okay. So yeah, and ta is big. So ji jian tai ta le. And if it is too small, you say ji jian tai xiao le. Xiao is for small. Okay. So these are the things. And if we want to say like I want this one, okay? Like if you want to say I like this one, so if you say I want This one for the clothing, we say wo yao na jian. This okay, we now will come. Wo yao na jian. Wo yao na jian. So that is that. And if you want to add a color, so we will say that wo yao na jian hong de. Hong means red one. So hong means red color. So hong de. Wo yao na jian hong de. That is all much. And let's go to the sports. So yeah, for calisthenics, I'm just in my pull-ups. Okay. Actually, while I'm studying, I'm missing a bit just like football. I haven't done anything. Yeah. I have to manage. And for martial art also, I haven't done anything. Actually, I was studying. I had the aim to complete the Dijkstra algorithm in 2 days. So I actually was in the home and I couldn't got the time to go on the ground. So actually I did the pull-ups and some dips at the push-ups, the push-ups, and some neck exercises and all that. So I did this all, and, and this was my aim. You can say this one was all the thing that I completed. The video has gone too long, because uh, I recorded and I explained, so I didn't uh, like imagine that it will go too long. So, xie zai qian. Actually, xie is thank you and zai qian is see you. Yeah, they say every time in when the lecture and in the course when in the lecture ends, they say xie thank you and zai qian see you. Okay, have a nice day. Oh my God, 36 minutes.